Welcome to April 29th LeetCode Challenge. Is graph bipartite? There is an undirected graph with n nodes, where each node is numbered between 0 and n-1. You're given a 2D array called graph, where graph index u is an array of the nodes at node u is adjacent to. More formally, each v in graph at u, there's an undirected edge between nodes u and nodes v. Node U and node V, I should say. The graph has the following properties. There's no self-edge such that the graph index U does not contain U. There's no parallel edges as well, so the graph at U does not contain duplicate values. If V is in the graph of U at index U, then U is in the graph V at index V at the graph as well. So the graph is unidirectional, so meaning that V is has an edge towards U, and U has an edge towards V, the node V, I should say. The graph may not be connected, meaning that there may be two nodes, U and V, such that there's no path between them. So a graph is bipartite if the nodes can be partitioned to two independent sets, A and B, such that every edge in the graph connects a node to set A to set B. So return true if and only if it is bipartite. So, for example, so is the following graph bipartite, right? So just by reading that there, we know that it fails the two independent sets. So there is basically 0 is connected to all the nodes, 1 is connected to two nodes right here. So the only two nodes, everything is connected together except for 3 and 1 directly. So the answer is false because it's not bipartite, because there's no way to partition between two nodes of two independent sets, such that every edge is connected to one node and one other node. So that's pretty much the idea. Can we make a bipartite graph using the cyclic square node? The answer is yes, because we have one set here, 1 and 3, they're set together, and 0 and 2, they're set together. So that means that in order to get from 0 to 2, you have to connect through the other set, remaining set 3 or 4, 3 or 2, 1 or 3. So that's what that kind of means. The constraints are that all values are unique, and graph of U contains in V, and graph of V contains in U. So meaning that if you have a node at V, it has an edge to U, right? And these are graph does not, so it's not, there's no cyclic pointing. So in order to solve this question, you first need to know the definition of a bipartite graph and a little bit of graph theory. So in simpler terms, I mean, they give a definition here, but basically you have if you have a more robust definition, you can give it. So basically a vertices is divided into two disjoint sets, an independent set, U and V, right? And every edge that connects the vertices of U to V will connect V to U as well. So these are called parts of the graph. So in order to identify the two sets, you could do something called coloring, right? Graph colors. So in order to solve this, there's two ways. Well, there's not two ways, but there's multiple ways. But what is a graph? So with any type of graph, you need to approach of how you could traverse the graph. So you can use a breadth first search or depth first search. Both ways work. I'm going to be using a breadth first search. So what we need to do is find alternative colorings of the node in adjacent levels. So if at some point we encounter an adjacent node of the same color, then of the same set, I should say, then the current node, meaning that the node being processed in the breadth first search, the code we can consider as invalid state, therefore return false. If it's invalid state, then we know that the input cannot be separated in two distinct sets. So basically, we need to find a set where, for instance, basically to fulfill these kind of properties, right? So first we'll start with the set. So say we call this a visited set, and it's gonna be a set. So every time we traverse through a breadth first search, we're gonna keep it and store it within our set. And the number we use a set because it's unique, right? Unique values, and yeah, we'll take it from there. So for node actually for node in the range of the length of the graph traversed through each node. So if node is not in visited checker set, if it's not in visit, then what we want to do is take update the visited set node at index to be 0. So we're using kind of a binary representation of the visited, right? Convert to null to 0. And I'm going to use a double-ended queue. So what we want to do is append the node to the queue. While queue exists, what we're going to do next is call an element, assign a variable called current, and we're going to keep track of the current node that we're on, and we're going to basically take it from our queue, our double-ended queue, so pop left. For next thing we want to do is find the adjacency between the two nodes. So node, say you call node 0 and then node 1, we want to find if they're adjacent or not, right? So for adjacency, adjacent in a graph between at index current, what we're going to do is find if it is if the next node adjacent to it is in our set or not. So if adjacent not in visited, then what we want to do is update visited to be at index j adjacent to be the visited at the current index to up. Oh, you also want to bit shift it actually. So let's do a caret here. Bit shifting. Because if it's a 0, then we want it to be a 1. If it's a 1, then we want it to be a 0, a 1 as well. And then q.append the current adjacent node. And then else if, so if it's not in it, then add it to our visit set, and then change the binary representation of our visit set to 1 at the index, and then append it to our queue. Else, if it's not in it, then we must know that we want to find out if the visited adjacent node, if it's not in it, then it must be equal to something inside it, right? Equal to the current node. Then what we want to do is, that means that 1 is in the same set as 0, and that means we want to return false, because there's not two colors difference. And then if it keeps on checking to see whether this is the same node set or not, if whenever it does exit this while queue loop, and exits this for loop as well, we could actually return true if everything goes well if it exits the while loop and the for loop. So you need to know a little bit about graph theory and like graph coloring for this. It's kind of it's medium because you need to know that knowledge, but once you do know it, it makes it relatively easy to understand. It's not the best time complexity because time complexity is basically big O of a number of vertices plus number of edges. So we basically go through each node, and each node we need to find whether they are connected or not. So we need to know whether they have an edge here or not. So we basically go through each node, which is a vertice, and each edge as well, adding them together. Big space complexity. Oops. Space complexity is big O of n, where n is the number of the color of the nodes. So basically for this one, you have n of 2 because n equal to 2, but it's because we have 2 colors here, 2 sets. Alright, that is it. Have yourself a great day, guys.